Hello, so in this video I'm going to talk you through how to do Spearman's row stats test, because I had a student today who was asking me how do you do it. So I'm going to go through some example questions and tell you what to write and how to work it out and things like that, so hopefully this will be helpful. So I'm going to start off with this scenario here about empathy and helping score that are interested if there's a correlation between the two. They've got 10 people given 12 questions assessing the ability to empathise, and same with helping, and they've got a score out of 12. So the first question is, explain why Spearman's rule would be an appropriate non-parametric test. Well, the first reason is that it's looking for a correlation. So let's see if I can do this. So this would be appropriate, as this test is used for investigating correlations, and this study wants to see if there is a relationship between empathy and helping behaviour. And then the only other reason that you pick a Spearman's rule is the level of data. So you can't do what's the other one? The design, because there are no designs. So it'd just be that the fact that it's ordinal data, because they are, so it said, indicate if they would help or not in a 12 hypothetical situations. So they've got a score 0 to 12. It's ordinal data, although, yeah, because we've not got equal in or have they, because it's a score. I'm just questioning this one because on the mark scheme it said ordinal, but collected scores out of 12 in each test. Let's see if there's anything else. Yeah, so ordinal data. So any kind of like rating, it's usually ordinal data. This study, in fact, let's just put it. It's also appropriate as the data collected is ordinal as both helping behaviour and empathy have been rated out of 12. So there you go, that would get you the marks for that one. Let's get rid of those. And then we've got use the formula for Spearman's rule provided to calculate what the answer would be, which is what RS stands for. And then we've got the value of this bit is 72, work out the rest. Now, this is really lovely because they've done most of it for you. So usually what you do is you would rank both of these, then you'd find the differences, then you'd square the differences, and then you'd total them all up and get this figure here. So that's already been done for you. So that's this bit in the bracket. So all we've got to do is do 6 times by 72, which if we get our calculator, so we've got, I don't know if you can see my calculator, but I've got it in the background if not, 432. So we've got the top line there, and then we're going to be dividing by this n squared minus 1 times by n. So n is the number of participants. It already told us there was 10 in there, so that's in the top of the scenario. So we've got 10 squared, which is 100, minus 1, which is obviously 99. And then we've got 10 times by 99, which is 990. I don't know why I had to calculate that, but anyway. So then in the calculator, you want to do the one that was on the top line. So we've got 432 divided by this that we've just calculated, so 990. So again, if we put that in the calculator, so we've got 432 divided by 990. This will get us 0.436, 0.436, 3636. But then it does say two significant, oh sorry, we've done that on the file, so we've got to do 1 minus this. So 1 minus 0.4343, oh wait, no, 4363636. So again, if we put this in the calculator, so we've got 0.4, 3636. That will get us 0.56364, and we want to do it to two decimal places, not two decimal places, two significant figures. So we're going to do 0.56. 0.56 should be our answer. Let's have a look at the mark scheme. So we've got 0.564, and to two significant figures we've got 0.56. Yeah, lovely. And that would be that one done. So that one's nice and easy. And then let's have a go at another scenario. So we've got another one here. Knowing me, knowing you, how well do we know each other, and how much does this reflect what we think of ourselves? To investigate this, psychologist asked 10 people again to rate their own extroversion level. And we've got a scale, so we've got ordinal data again, and then asked a close friend to rate them on a scale. So it says, explain what P is greater than 0.05 would mean in the significant statement for the results from the study. So 0.05, if it's above 0.05, it means, so let's put this means that there has not been a significant relationship found between how someone rates their own extroversion and how a friend rates them. This is because the probability of the results being due to chance is above 5%. So let's just see what the mark scheme says. So we've got the probability of there being no relationship between by a friend is greater than 5%, meaning that this is not a statistically significant result. There is no relationship between them. So yeah, they've done it in a different way to the way that I've worded it, but same answer. So that one's nice and easy. Let's get rid of them. And then we've got, given that the value is d squared, so they've done the d squared bit. No, in fact, no, they've done the same thing as last time, haven't they? They've added up the d squared bit, so that's the sum of the d squared. They've not been very clear there. That should say like the sum of. So again, let's times that by 6, which equals, we've got 270.5 times by 6. And don't ask me why they times it by 6. There's some maths magic that goes on that explains why this works and allows you to find out this information. So we've got that there, and then we want n, and they said 10 people again, so it's the same one as last time that we worked out. So we're going to be having that 990 because there's 10 people. So we want to do this one divided by this one. So let's say divided by 990. So this is 1.63939. And then we've got to take all that away from 1. So that will get us 0.6393939. In fact, is that right? 1 minus 1.63939. It's going to be a negative, isn't it? Always good to check. I thought my gut wasn't telling me that was right then. So we've got a negative correlation for this one. And yeah, something important to kind of point out on these is that this result is telling you the correlation, like coefficient at the end of it. So yeah, the mark scheme is saying 0.639. Just wondering if it's sharing the right window or not. Hoping it is. Otherwise, you can't see anything I've just spoken through. Anyway, so we've got, let's just see what the question said. Give that use the function to calculate the show your workings. So in this one, I don't think it's asking for any significant figures. Let's just see. Yeah, usually you do it to like a correlation coefficient. So you do it to two decimal places, so it'd be minus 0.64, and that would be your answer to that one. Let's get rid of some of these. And then we've got put the letter of the correct answer in the box. Which of these would be a Spearman's rule? So this again is showing you like an example answer for what you might get for the end of the test. So it needs to be between 0, it's between -1 and +1 because it's correlation. So it's not going to be D, so that gets rid of that one straight away. And it's not going to be these because they're too big, they're above 1. So already we know that it's going to be A. So once you kind of like know what coefficient is, that's quite an easy question. So this one would say that we've got a moderate correlation, whereas the one before here, so in fact that's a moderate wait, hold on, no it's not. 0.05 is like a very, very weak correlation. It's almost no correlation, to be honest, so they're not very good. This one before -0.64 is a negative, moderate to strong correlation. Usually 0.7 is like a strong one. And then what else did we have before? We had a 0.56, which again is a moderate correlation. And let's see, so we've got explain why Spearman's rule will be appropriate in the data. So it'll be the same as before. So it'll be, in fact, let's just copy and paste our answer from before. So we've got this bit, and then we're going to put that here. But this time we just want to put it in context of this scenario. So this time it was between rating extroversion themselves and other people's rating of their, was it extroversion? Let's just double check. Yeah, I think so. Let's just spell that right. And then we've got because both statements we'll put have been rated out of, what was it rated out of 100? So see, nice and easy to get your context on that one. Then we've got another one about extroversion, interesting. So this one's about how much people earn and extroversion, and they've already got the ratings here, but then they've already ranked them. So they've already ranked, and it's asking you to do the difference and then square up and add the difference. So it's a little bit more tricky, this one, to do. So let's see. So we might be better putting on a little thing here. So we'll do the difference here and we'll do difference squared here. So 989 is nothing. So the difference is nothing. And then let me just get my calculator because it'll be quicker. So we've got 10 minus 6.5, which is 3.5. We've got 1 minus 11.5 is minus 10. Oh, minus 10.5. It doesn't really matter about the minuses because once you square a number, it's going to get rid of them anyway. Got 7 minus 5 is 2. So 1, 1, 1. Okay. And then we've got, oh, I've got more. 11 take 10 is 1. 6 take 8 is 2, 3, 1.5. 0.5. I was thinking that that's not right. This is why I just prefer to do it on a calculator and then I don't make any mistakes. 1.5. And then we need to square them. So 2.5 times 3.5 is 12.25. We've got 10.5 times 10.5, 110.25. It's 4111. 141. 0.25. I don't know how to calculate that one, but there we go. Times 1.5, 2.25. And then we need to total all of these up. So let's see. So we've got 12.15 plus 10.25 plus 4 plus 3 there plus 1 plus 5 plus 0.25 plus 2.25. So we've got, feels like this might not be right because it's so big, but we'll see, 133.904 as the top line. So we need to times that by 6 because that's our d squared total. This sigma sign stands for total. So then once we've timed that by 6, we've got 803.424. And then we need to divide it. So this time, how many participants we've got 9. Doesn't tell us, so let's count them up. So we've got 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. We've got 12 people this time. So we want 12 times 12, which is 144, minus 1 equals 143. And then we want 12 times by 143, which is 1,716. And then we want the 800, this one, divided by this one. So let's see what that is. So we've got 803.424 divided by 1716. So that is 0.4681. I've got to take all that away from 1 to get what our correlation is. So let's see if we can put this in memory. Got 1 minus that. So it should be 0.5318. And then usually a coefficient is 2 numbers. So we've got 5, 3. Let's see if this is right. I hope it is because that took forever. So we've got 0.517. Oh, where's that come from? So they got 138 for the, oh, am I looking at the wrong one? Oh no. Difference is squared of 138. Oh, because now times it by, oh, so we got slightly different results here. That's weird. Got 133. Let's go back and check our calculations. If we've got a mistake anywhere. 10 minus 6.5. 8.5. 10.5 minus 2 is 3. There we go. Oh wait, hold on. 5, 6, 7. No, that is fine. 5, take 4. 2, take 1. 6, 3, 11. 8. 3, 2. That's weird. Something else. How strange. Maybe it was minus 10.5 times minus 10.5. Oh. Oh no, I was like, that's wrong. Minus 10.5 times minus 10.5. Minus 10.5 times minus 10.5. It's minus 20. Why does that keep doing that? Let's look at that in Google. Let's see. Very odd. Because you'd think, but then maybe the 0.5s affect it. 10.5 times 10 minus 10.5. Yeah, 110.25, which is what we had. So then maybe there's an issue with how I added it up. Let's see. So let's get back on the calculator. We've got 12.15 plus 110.25 plus 4 plus 4 plus 5 plus 0.25 plus 2.25. So now I've got 137.9. Or maybe I just put it in wrong. So I did definitely add that up wrong. So let's times that by 6. So that's now 827.4. And then we've still got the same as that. So let's copy that. So it's always possible to make a mistake. Let's see. So we've got divided by 1716. It's 0.48216. Copy that. Take that away from 1. So we've got, that's not right. We've got 1 minus 0.48216. So we've got 0.51784, which we would generally say 5 point, although they're saying 5.17, so that's fine. Right, so it's always really good to check a mark scheme because, you know, you never know, do you, what the answer is going to be when you're practicing, and then you can spot your errors. So we just got to be super, super careful that we add them up right. I must have just put the wrong number in when I was typing. Easy to make an error. And then we've got to notice that that one's for 5 marks, which is a bit cheeky, really, isn't it? Because the other one was at easy and that was for like 3 marks. But yeah, if you get a 5 marker, they're probably wanting a bit more. And then we've got, they want the critical value next. So let's say we've got a critical values table. And on that one, we had 12 people, didn't we? So we want to go to 12. And we want 0.05. So we've got 0.587. So 0.587. So add its critical value. I think that's all you need to do. Let's see. Yeah. Yeah, you don't really need to put anything else. It's probably good to put your working on because if you do get it wrong, they can still give you a mark for it if you've got working out on. So we've got sample 12 and then sig level 0.05. So the significance level. Right, a significance statement. So we've got observed value is what we found out before, which is the 0.517, sorry. And we've got the critical value is what we've just worked out here. So we've got this one. And in order to be significant, so significant, the observed has got to be, observed has to be bigger than critical value. So when we look, is the observed bigger? No, so there is not a significant relationship between is it income and extroversion, put salary and extroversion as the observed value is less than the critical value at 0.05% significance level. Let's just see the mark scheme and just see. So we've got is smaller than the critical value and P is less than the null hypothesis 40. There's no relationship. Yeah, that's fine. So you can also say the null hypothesis would be accepted and the alternate rejected. You could say, instead of this one, you could put P less than 0.05. Yeah, there we go. So there's enough there to get you the marks for that. And then we've got exercise your stress. So we've got, again, 2 ratings. We've got how much you exercise and stress. That's what it's about. Again, why would it be appropriate? Exactly the same as last time. So let's copy and paste. So we've got this one here. Here. So we've got This would be appropriate because in correlations, and this study wants to see the relationship between stress and exercise. Get rid of that. And then we've got, it's also appropriate data collected on it as both rating stress. Let me just check the marks given on this one actually. Correlation to least ordinal data collected. Yeah, what we're going to put on this one, because actually technically that's not ordinal level data, that's kind of like an interval score. So what we'd say is it's at least ordinal. So whereas the data collected is at least ordinal, as both rating stress as stress is rated on a scale, and what was the other one? And amounts of exercise. Let's just see, so we've got, see, it's not saying you actually have to stay. Yes, we've got the stress on a scale, and the amount is as positives. This data is at least ordinal stress is rated on a scale, and amount of exercise is per month. Technically that one is interval, but I won't put it in the answer because it's just not really needed. I think that's probably fine. And then we've got the R is minus 0.37. What does this mean? Well, this means there is a negative correlation that is relatively weak, which suggests as exercise increases, stress decreases. So let's see what the mark scheme says for that one. Yeah, weak negative correlation. Yeah, that's fine. And then we've got another one. Are you getting bored yet? I am. So we're looking at maths and physics to see if they're correlated. Do people do similarly or not? So we've got explain why this was an appropriate test to use. So it's the same as before. This time we've obviously got maths and physics scores at interval data. But you can put at least ordinal, so that's fine. And then how the data would be ranked. Well, you give them a score from lowest to highest. So for example, 4 would be 1, and then that'd be 2, and that'd be 3, etc. And you do that for each column. Let's just have a look at how we would word these. So yeah, we've got test scores would be assigned a number using rank 1 for the lowest, rank 2 for the next, and so on for both the maths and the physics, but each set of scores are ranked separately to each other. So that's what that one's about. So let me just copy that from the mark scheme, save me writing it out. And then the other one is, why is it appropriate? So again, we've got, because it's testing for a correlation and because it's ordinal data. Although I wouldn't call that ordinal, I'll say it's at least ordinal. At least ordinal data was obtained. Right, lovely. So hope that was helpful and that you understand Spearman's Law more. And I really do hope that it's actually recorded all of this in the right way. So let me see if I can stop my recording and I can see if it's actually worked.